Good morning, Year 11. So we're going to do your Wednesday, the 1st of April's revision session now. So I've got a bit of algebra and then some shape to do. So question number 1, expanding the bracket, we're going to multiply 2a by a. That gets us 2a squared. And then we're going to multiply 2a by 3, which gets us 6a. Factorise, you need to bring outside the highest common factor of both these terms. The biggest number that goes into 6 and 10 is 2, but there's also a common letter to both these terms, which is y, so bring that outside the bracket as well. What do you times by 2y to get 6y? That will be 3. And then what do you times by 2y to get 10y squared? Well, 2 times 5 gets you the 10. Y times another y gets you the y squared. Bit of solving. We have a fraction, so the first thing we want to do is to remove the divide by 3. So we're going to multiply both sides by 3. That effectively gets rid of the divide 3 from the left hand side, and on the right hand side you need to multiply this now by 3. So we have 2y equals 12. We now divide 12 by the number that sits in front of the y. 12 divided by 2 gets us 6. Solving with a bracket, there are two ways you can do this. You could divide 24 by 2 and then you just have the bracket left. However, it's probably going to be easier for us to expand the brackets because that will always work for every case. So 2 times x is 2x. 2 times 4, which is 8, equal that to 24. Now we need to remove 8 from both sides. So 2x's equal 16, and then 16 divided by 2, so 1x equals 8. Little bit of indice work now. We are multiplying, and these two terms have the same base number, so all we need to do is to add the integer values. So 6 adds 7 gets us 13, so a to the power 13. When dividing, we take those powers away, so b to the power of 6. When we have a fraction, add the two top indices together. So the base number is 3, so we're going to keep a 3 on the top. Add the two indices, you're going to get 8, and then the denominator is 3 to the power of 3. We are now going to use this fraction as a division, and now we're going to take those powers away. So 3 to the power of 5. Even though the base number is a number instead of a letter, the base number remains the same. Lots of people get confused and start doing things like 3 times 3. It's not what you do. The base number remains the same. When you have a bracket and then a power, you apply that power, so the squared, to everything inside the bracket. So that means to this 3, but also to the a to the power 4. So you're going to square the 3, which is 9, and then you're going to do a to the power 4 and then square that, effectively timesing the two numbers together. So a to the power of 8. Anything to the power 0 we should know equals 1. When you have a term times by a term and you've got numbers and letters, multiply the numbers, those integers, together. Now for this one, you can't actually do anything with the powers because the base numbers of the power are different. You can only add when the base numbers are the same. So the only thing we can actually do with this one is 2 times 3, which is 6. A has to stay as a base of a squared, and then the b also has to stay as a b. If that was an a, then you could add the powers, but we can't. Right, 80 as products of prime factors. You should all be able to do this one really well. We need to do our factor tree. Break down 80 into 2 factors. I'm going to go 10 times 8. They are not prime numbers, so go again. 10, I can break that down to 2 times 5. 8, I can break down to 2 times 4. 2 is the prime number, 4 is not. I can now break 4 down into 2 times 2. In your exam, you must then write that factor tree out. So to get 80, now we've got a 2 times 2 times 2 times 2. I can write that as a 2 to the power 4. You must write your multiplication sign and then any other numbers you've got left, all being times together. No commas, no adds. This next question is for the higher tier people only. You're expanding 3 brackets. Start by expanding a double bracket. X times x, well, that's going to be an x squared. X times 4 is 4x's. 3 times x is 3x. 3 times 4 is 12. Simplify that. So add those middle 2 terms together. We have x squared plus 7x plus 12. Now, there's not that much space on this page. Hopefully in your exam you'll definitely have a bit more space. It'll make it a bit easier. We're now going to multiply the result of those 2 brackets by the 3rd bracket. So we've got an x and then minus 2. Let's times that all together now. X times x squared is x cubed. X times 7x is 7x squared. X times 12 is 12x. Negative 2 times x squared is minus 2x squared. Minus 2 times 7 is minus 2 times 7x is minus 14x. Minus 2 times 12 is minus 24. We can now add those bits together. Remember, anything with the same base number and the same power, we can add the whole numbers in front together. So we've got x cubed. Now, I don't have much space, so I'm just going to write my answer over here. So we've got x cubed. We then have 7x squared minus 2x squared. So that's going to be 5x squared. In an exam, you can write this out in a nice long line. Minus 14x. Add 12x's, well, that's going to be minus 2x's, and then minus 24. There we go. Squeezing it over there. Right, a bit of perimeter and area now. So these don't have measurements on them, but we can take it to be each square being 1 centimetre squared. It will tell you that in the exam. You could count the square for this one, or count the squares. Anyway, I'm going to do it by calculating the height, which is 4, and then the width there, which is 3. To get the perimeter, you need to add all of those together. I know I've got 4, add 4, which is 8. And then I've got another 3, which is 6. And I can add those together to get me 14 centimetres. Alternatively, you could have done 4, add 3, which is 7, and doubled it. Or you could have just gone all the way around the outside and added those lengths together. Area, this way you're going to multiply the length by the width for the rectangle, so 12 centimetres squared. Calculate the area of this triangle. Well, you're going to do base times height divided by 2, which you all know the area's formula. So base, which is 6, times the height, which is 8. 6 8s are 48. Half of that, you're going to get 24 centimetres squared. And then for our parallelogram at the bottom, base times height for that one. So 24 centimetres squared. Okay, so I'm going to press pause on the video whilst you have a go at those questions there on the right. And then you've got some more questions on the other page. So press pause and then play when you're ready for the answers. Okay, so let's go through the answers. I haven't pre-done these ones, but I have on the other side. So this one, the perimeter is 14 centimetres. It's actually the same shape, just on its side. And the area is 12 centimetres squared. For the triangle, you need to do the base, which is 12, times the height, which is 6.5, and then half your answer. And I'm getting 39 centimetres squared for that one. And then for the parallelogram, we've got a base, which is 8, times the height, which is 3. So 24 centimetres squared. Okay, your answers for the other one. So you should have got 7a squared plus 21ab. X squared plus 5x plus 6. And then for your triple bracket, higher tier only, x cubed plus 8x squared minus 3x minus 90. Factorising 7y brackets 1 plus y in brackets. Factorising 2x on the outside, 4x plus 5 on the inside. Solving x equals 6, x equals 20, x equals 7. Simplifying your indices, a to the power of 8, and then you end up with just a b. Products of primes, 2 times 3 squared times 5. Now, question 8, I didn't really go through this one. Hopefully you managed to work it out, but if not, here's what you needed to have done. You have to find the highest common factor of a and b. So that means you're going to split up a into its indices. So 2 squared you're going to write out as 2 times 2. And then for b, you're going to write out the 3 squared as 3 times 3 with all the other numbers. Highest common factor, that is your pairs. So you pair them all off. And then you just write out one number from each pair and times them together. So the highest common factor was 6. Lowest common multiple is where you get the highest common factor and then you times it by all your spares. So we're going to call that pairs times spares. And I get an answer of 1,260. A to the power 0, anything to the power 0 is 1. Expanding out your indice, 64 a to the power 6. For this one, the area of the square is 100. The area of the circle is 25 pi. To work out the area of the shaded part, 100 minus 25 pi, so 21.5 centimetres squared. And trapezium, you possibly have to look this one up because I didn't go through this formula. You have to do the base added to the top, so 8 add 10, half of that, and then times it by the height. And you get 36 centimetres squared for that one. So last little bit today then, we're going to look at force, pressure and area. You do get given this formula in the exam, so that makes life a little bit easier. Force is always measured in newtons. Now area, they may give you the area in centimetres, hopefully metres, that'll make your life a bit easier, because pressure has to be measured in newtons per metres squared, or that's what it is normally. So to answer these questions, I am going to convert the areas to metres. Makes it a bit trickier. Hopefully in the exam they give it to you metres already, but if they don't, convert it to metres. They will tell you on the answer line what they want the units to be. So over here we've got 6 centimetres and we want to work out the pressure. So to get pressure, if I look at my little triangle over here, I need to do the force and divide it by the area. I'm already given the force, which is 6 newtons, and I now need to work out the area. That's going to be the area of the base. Now I do want to work in metres, so I'm going to have to times 6 centimetres, divide 6 centimetres by 100, so 0.06, and I only need the base, so I just need that 2 there, 0.02. So I now need to get the area of the base, so I need to do 0.06 times 0.02, so that's going to give me an area of 0.0012. The force is given to us, so we need to do 6 divided by 0.0012, and that's going to give us 5,000 newtons per metres squared. This one is a cylinder. Now we want to work out the pressure. We have the force. We need the area that the cylinder makes with the ground. Because it's a circle, we need to work out the area of the circle. So again, I am going to do it in newtons per metre squared to make sure that the units are correct. 7 centimetres, I'm going to divide that by 100 to get 0.07. I can now work out the area by doing 0.07 squared times by pi. And to get the pressure, I need to divide the force by the area. I'm just going to run that through my calculator in one go. So 10 divided by 0.07 squared times pi, and that's going to get me 6,411.4 newtons per metres squared. Okay, this next one's really similar. So 6 divided by 100 is going to turn that into 0.06 metres. To work out the pressure, I need to do the force, which is 12 newtons, divided by the area of my circle, so 0.06 squared pi. and put that through my calculator. And make sure you're putting it through your calculator as well. 10,471.98 newtons per meters squared. Okay, last one. We have a cuboid here. We only need the two measurements at the bottom, the 7 and the 2. Convert them to meters, so 0.07 and 0.02. And then you need the area of the base. So you're just going to multiply those two together. And to get the pressure, we're going to do 3 divided by 0.07 times 0.02, which is 0.014. And we're going to do 3 divided by that number. And we get 2,142.9 newtons per meters squared. Okay, so have a go at the questions on the other side. Please do convert all your centimetres into metres, so then you can leave your answer as newtons per meters squared. Press pause and then play when you're ready for the answers. Okay, here are your answers. So for question number 1, you should have got 5,000 newtons per meters squared. For question 2, you should have got 8,726.6. For this one, now this one was a bit sneaky. The units are in newtons per centimetres squared. It should really be in metres squared. However, using the formula, the force divided by the pressure gets you 4 centimetres squared. And the last one, I think I've just realised I've actually done something wrong with that one. So I'm just going to make a correction to that one now. We just want the area of the base. I did the area of the whole thing, the volume of the whole thing. We just want 0.06 times 0.02, which is going to be 0.0012. Just going to correct that one now. So we're going to do 0.06 times 0.02, which is 0.0012. And then 3 divided by 0.0012. So you should have got, and hopefully did, 2,500 newtons per meter squared. So it wasn't the volume, it's just the contact area that that cuboid makes with the ground. Okay, it's a little bit of a shorter video today. If I have made any mistakes on there, you spot anything, please let me know and I'll write that in the comment section. I'll also be setting you guys some MathsWhat's questions on force, pressure and area, and a little bit of algebra, a bit of number work, and some perimeter and area. Thanks guys, have a good day, see you later.